So this is the writer Thomas Mann, who wants to define a writer as someone for whom writing is more difficult than it is for other people. And what he meant by that was that the more he learnt about writing, the more he found there were things he could be doing or should be paying attention to, and he found it much more complicated than he had when he was starting out. And in a talk a couple of months ago, Lawrence Barry talked about the Dunning-Kruger effect. How many people have heard of that Dunning-Kruger effect? So it's the idea that when you're starting out at something, you don't know how good you are. You're not able to adequately gauge your performance against other people. So you tend to be much more optimistic about how good you are compared to people who are experts. And experts tend to know how many things they don't know and tend to be much more reticent about how good they are. So the Dunning-Kruger effect is why people who are really good at things will be less vocal about being good than people who are perhaps less competent. So a lot of stuff in Spring, people talk about how simple things are now with Spring and Spring Boot. And I think Spring Boot is amazing. I remember like the old days when every website you built, you had to kind of start by building your own frameworks and everything else. Whereas Spring Boot and Spring just plug in databases, integrations. You can get stuff up and running fairly quickly. And this picture here shows a famous tweet where somebody showed the smallest piece of code you could use to put into one of the Spring code generation utilities and get a working service up and running. And obviously that's fantastic. You can get a fully functioning application and environment just from a simple tweet like this. But the thing is, like, it's not how easy it is to get a piece of code up onto the web. It's how easy it is to keep it running perhaps months or even years down the line. So I want to talk about issues around technical debt, around the fact that we've got this kind of appeal to put things for live the simple way, but actually we probably need to be focusing on a slightly harder way. And this talk is going to be in 4 stages. So the first stage is an introduction. What are the problems that happen when you build up technical debt, when you do things perhaps in an easier way than you should have done? The second part, I'm going to talk about the Agony principle. So the Agony principle is a term that you hear a lot in Agile. You ain't going to need it. The idea that you try and avoid building things into your application that perhaps you won't need until further down the line. I'm going to talk a little bit about that and technical debt and the trade-offs that are made. The third part is a subject that I'm really fascinated by, which is testing. I think a lot of issues with technical debt tend to occur around testing. It's something I've seen time and time again. And finally, I'm going to talk a little bit about what to do in those situations where you've built up technical debt and you need to basically get rid of it. So does anyone else recognize that screen? Am I the only person? So yeah, this is a screenshot from the computer game Civilization, which came out back in 1991. And I probably played far too much of that when I was younger. And Civilization, you start out with this single settler, and you build a city. And you start expanding out and expanding out. And eventually, after a couple of hundred turns, you'd encounter another civilization. And they perhaps would be stronger than you. And you generally win or lose the game in the first 50 turns. The first 50 turns, how quickly you could start expanding, would dictate how good you were later in the game. The big problem being that you wouldn't work out how well you'd done until you came towards the later stage of the game. And that's something that I sort of see a lot in development, where decisions that are made early in the process of developing an application or a site or a platform tend not to sort of show how effective they were until years down the line, when you're struggling against competitors, other things are happening, and perhaps it's a little difficult to easily deal with those issues. You end up in situations like this, with complicated situations and technical debt. And you end up with things like simple issues with deployments that you've never quite got under control, become more and more nightmarish. So something that perhaps you need to spend a week on fixing, you don't quite have that week. So you lose a day again and again and again from these sort of issues. And it's a little bit like not paying off a credit card debt. You can pay the interest payments as they go month on month, but you're never paying down the capital. And eventually, you get to the point where the interest payments grow and grow until you get that choice between paying off the debt or paying for food. So what are the sort of problems that we encounter with technical debt? Well, firstly, deployments. Ideally, you want to be able to deploy new code quickly. If a bug turns up or if there's a new opportunity, you want to get this code out as quickly as possible. And obviously, if you've built up technical debt, it can be very difficult to get these deployments out. Another problem is you often see is deployments failing and needing rolling back. So even when you get this thing together, you have all the effort of going to this big launch, it all falls over when it's on the site, and you have to panic about whether to throw up a patch, take back the new deployment. Again, it's nightmarish, it's stressful. Another issue is that new code becomes more and more difficult to add. Things are tightly coupled, and you find that making a small change somewhere breaks something on a part of the site you've not looked at in years. And it gets harder to add tests because you need more and more structure to build that up. Dependencies become out of date. So I've seen a number of situations where people have used frameworks or libraries that have then become out of date and not been able to upgrade them. And this is something, again, I've seen it time and time again, where the work required to update that dependency is always too much to do at any particular time. But later on, it becomes a more and more costly drag on the company. Developers come to hate the code. People start to sort of become incredibly unhappy about the code that they work in every day, which is obviously a bad situation. You also end up with the situation where the experienced developers tend not to want to work on it. So consequently, and it's happened in sort of most companies I've worked in, the support of the code, the really difficult thing to do, is left to fresh and inexperienced developers, whereas the experienced devs get put on the greenfield stuff that's relatively simple and straightforward. Again, sort of a huge problem. You end up with like strange errors occurring, which you never get to investigate properly. You end up with the logs just full of errors, and you can't really track back exactly where they've come from. And then there's the classic non-functional requirements like speed. So early on in a website's development, it'll be snappy. It's fairly hard to sort of release the site in its first version and have it working slowly. Later on, that slowness sort of creeps in more and more until eventually the site's annoying your users, it's frustrating. By that point, it's incredibly expensive to try and fix. So putting a site online the first time, that simple piece of Spring code we saw is one thing, but actually we need to kind of strike a balance between getting stuff out there early and making sure that it's going to be sustainable even months or years down the line. And there's a lot of freedom from a greenfield site, but fairly early on you're making these trade-offs between stuff to get it out there into the world now and things that are going to produce problems later on. So who here has used the term or heard the term used Yagni? So, okay, so about a third, I think. So Yagni, this idea that you ain't going to need it, which is something that people say quite a lot. I think occasionally gets used without people thinking about it fully. So it's a call for simplicity, the idea that you often hear people say, oh, if we just did a bit of work here and added in a proper user management system today, we'll save months of work down the line. And that trade-off between saving time now for time in the future is often quite a wasteful one. You need to stay focused on what you're releasing at that particular time. However, you also need to pay the trade-off, the fact that these decisions to do stuff later are eventually going to come back to you, and that's what we refer to when we talk about technical debt. So the term technical debt appears to have come from a guy called Ward Cunningham back in 1992, and this is the quote where he first mentioned it, about how shipping first-time code is like going into debt. He said that little debt speeds development as long as you pay it back promptly. Now, in this particular example, he was talking about the relationship between the objects you've created and the actual problem. And he felt that the technical debt was actually the gap in understanding, the fact that your first release, your objects wouldn't perfectly match to the business process perhaps you were working with. And he had quite a specific aim in mind. And as he said, the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest. Entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. So like I say, very specific thing that was talked about. But what was powerful about this was it took a very complicated idea, this nebulous idea that a trade-off between doing something now and doing something later has a cost. By referring to it as debt, it's something that we instinctively understand debt. Business people have a very clear idea that, okay, there's a trade-off here, borrow some money here, lose it later on. It was a very powerful metaphor, and it's come now to very much be seen as this trade-off of taking shortcuts now, losing time in the future, but having the opportunity to bring out more stuff quicker overall. And the main point is that technical debt is generally a good thing. So most businesses, when they start out, will borrow money from the bank to perhaps buy machinery, to perhaps buy equipment, and then slowly pay it back. The idea of taking on debt allows you to do much more and expand much faster than you could have done if you didn't have that debt to take on. And the Agni principle is this idea that you should be taking on these debts carefully. Don't buy stuff you don't need yet. Wait until the right time to buy it, and buy only the stuff that's most valuable now. So we obviously had this situation where there's good debt and bad debt. And good debt is this idea that you keep track on how much technical debt you have in the system. It allows you this flexibility. You don't run into the problems that we talked about earlier where you're restricting what you can do because you're fighting against the system all the time. But occasionally you might say, well, we need to get this import system built really quickly. So you cobble it together really quickly, get it up and running, and perhaps it doesn't need much maintenance. That's fine. And technical debts, some of them, obviously, you pay back interest every month. So problems with deployments will tend to turn up regularly. Problems with systems that you don't really deal with a lot, those will be a fairly cheap debt. Of course, there's other debts which tend not to get asked for repayment very often, but when they do, it's kind of leg-breaking time. You've got a lot to pay back. So obviously, we want to avoid the situation where the technical debt blows up. High technical debt means riskier changes. It means depressed developers who don't really enjoy working with the code. It means a lot of frustration by management wondering why things aren't happening immediately. It means people being stuck on out-of-date platforms and their skills coming out of date. And the interest has to be paid back on this debt. And sometimes it gets written off in other places. So for example, more support calls, angrier people phoning into the business, rather than basically being taken on by the developers who've decided to make that trade-off. Ernest Hemingway once was asked the question, how did you go bankrupt? His response was 2 ways, gradually, then suddenly. Nobody sets out to end up with crippling technical debt. Nobody says, yeah, let's just kind of keep just pushing to release and we'll deal with it all in the future when the creditors come to call. Every trade-off, though, slowly makes these decisions that lead you further and further into this debt. Which brings us back to this idea that things like Spring Boot say, which is getting to production is really, really easy. This tiny bit of code is something you can get onto a server pretty fast. And Spring Boot's great. It introduces features like metrics, health checks, externalized configuration, dependency management, integration. It plugs in really beautifully with things like continuous deployment, and continuous delivery. But then there's still a load of other things that need doing. Monitoring and alerting, logging, backups, failover, security. These are all things which, for that first release, perhaps don't seem that important. For that first release, it's going to be fairly easy to track when there's been a problem with the site. You're not going to have to worry about your logs overfilling early on in the site. Those first few days, you can use MySQL dump to back up the database, and that's fine. Later on, that's going to be much more of a problem, but in the early stages, it seems like a good trade-off. And while features are obviously the driving thing you want to make sure to do, a lot of people don't keep track of these little debts they've made, these little deals they've made that are eventually going to come calling. And the problem is that some things do get more expensive the more you put them off. So for example, managing backups properly is something which, in the early days, would be fairly simple to add. Later on, it gets trickier. Doing continuous deployment can then get trickier the longer you leave it. And this is the thing that you need to be aware of, is that when you're taking out these technical debts, they're actually an investment. So while it is that features are exciting, features look grand and amazing, you also need to make sure that you're always going to have the infrastructure that will support those features. So when we do this Yagni principle, we need to treat it as a financial trade-off. It requires us to be really good at refactoring, keeping the price of adding new features low, and not making changes that further reduce your ability to pay off this debt. You also have the trade-offs that produce sort of nightmare situations. So somebody gave the example when writing about technical debt of somebody saying, we're going to store our passwords in the clear for now. Later on, when we have more users, we'll put a proper challenge response in. That's obviously a bad idea. But security is one of those things that's absolutely frightening. So this is what I was saying about expensive technical debts. Having security, sort of skimping on security is a little bit like borrowing money off dangerous criminals and loan sharks. They might not ask the money back immediately, but when they do, they'll expect a lot of interest and they'll expect it very quickly. And having your site defaced, having your data stolen is one of those things that can be incredibly costly. I'll put some links with the talk on the website after this, but one thing I definitely recommend, has anyone read this Basics of Web Application Security? No. Fantastic guide to just all the things that you really need to know. It's an evolving publication, being updated regularly. I recommend tomorrow, sit down, have a read of that over a coffee, just make sure that you're kind of up to date with everything that's in there. So one of the interesting things I found with kind of building my own platform, so this is like a fairly early build 14. I just added Jacoco, and the coverage was 0, despite the fact I put unit tests in. And what amazed me is that even with just Jenkins, Jacoco, and Gradle, already at that point, I had a system that had clashes. Gradle and Jenkins just didn't play nicely together. So even in that stage, I had a problem where I didn't have an obvious upgrade path. And it's one of those things where I'm kind of grateful that I'm facing it early on, that I'm just kind of putting all this stuff in place rather than adding the features, because at least it means that I'm not going to sort of get underway, have the demand of customers, and then also have to work out when I'm going to add the code coverage. I think one of the big places where technical debt really becomes apparent is with unit testing. So who here uses unit testing? Sort of show of hands. So pretty much unanimous. I won't sort of. And out of those people, who would say that they use test-driven development? Okay. And who's using test-driven development with coverage over 90%? So there's yes, there's a few hands there. So unit tests tend to be one of those places where technical debt becomes particularly apparent. So for example, I've worked on a lot of systems where you make a change and unit tests break all over the place. A simple change and perhaps dozens of unit tests suddenly start breaking. Situations where one test setup affects a later one. So if one of the tests fails, every other test that follows it breaks. You get situations where adding new unit tests becomes nightmarish because you've got so many mock objects to set up, and before you know it, there's 30 lines of code before you've even started your actual test. Other situations where the test works sometimes, works other times, fails other times. So I've worked in offices where you kind of had a handwritten list of which tests failing didn't block the build. And you kind of have to get to know the code really, really well before you could put it live. A lot of people say with unit tests, the ideal length of time for a unit test to take is no longer than a cup of tea. And obviously, if the unit tests take a long time, it's harder to run them. It ends up causing problems with putting commits in together. So obviously, another place where technical debt occurs is in the unit test taking a long time. And you get a situation where some tests just sort of break a lot, which, I tend to think there that a bad test is worse than no test, but a lot of people disagree with that. So with test-driven development, obviously the test-driven development cycle, add a test, watch it fail, write code, run tests, and refactor. I think that test-driven development, as opposed to writing the tests and then the code, is a particularly good way of preventing a lot of problems. So for me, test-driven development is very strictly this coupling of the test code and the code under test. The idea that they should be very closely linked. And so much so that you shouldn't have any line of code added unless there's a failing unit test. You should never add more lines of code than you've got for unit tests. And obviously, one of the big controversial points about code coverage is what level of coverage should you have? And I think there's only one sensible answer, particularly if you're using TDD, which is 100% or pretty much close to it. I think I'd be happy to sort of discuss this later. Because the big question is, what are you not going to cover with TDD? And also, if you're using TDD, then by definition, you should have this very tight coupling between your unit tests and your code, and you should be somewhere around 100% coverage. But one of the things I find fascinating about TDD is it tends to produce code that behaves in a certain way in order to make it more testable. Certain patterns tend to develop. So for example, I tend to use a lot fewer subclasses now because they make more problems for unit testing. And obviously some people say you shouldn't be changing your code to make it testable. I think that's one of those things that tends to get said in a well-meaning way without perhaps thinking through all the ramifications. So obviously it's bad if you've got private member variables that have been changed to public just so you can check on them in a test. But equally, I think there is the angle of as you do more and more TDD, your actual style of writing the test tends to change a great deal. That's one thing that I'm finding particularly fascinating. So for example, I've seen a lot of places where there's manager classes that tend to be these huge monstrosities where all this code's been kind of put because there's nowhere better to put it. Whereas with TDD, I'm tending to produce much smaller classes, and my managers tend to be classes that they tell other classes what to do, but don't do any work themselves. So the question is, why does TDD tend to not work for a lot of people? Why are a lot of people using test-driven development and standing up with technical debt? I think the answer is because TDD is really difficult. If you read a lot of the debates online, tend to be involving either Bob Martin or Kent Beck. They tend to get involved in these huge debates about unit testing. So there's a fascinating argument with DHH, the guy who wrote Ruby on Rails. There's been a couple of recent arguments about TDD. And they tend to be incredibly furious, and a lot of people feel that the case isn't made. But one thing I'm finding with TDD is that I've probably been working with unit tests for about 15, 16 years now. I still feel that I'm only starting to grasp how to work with them. And obviously Luke mentioned the coding dojo. So I keep doing sort of dojo sessions with different groups and learning different aspects of the way unit tests work. And I've come to feel that test-driven development is almost a hack just to keep your unit testing high, to keep your code easily refactorable. And that seems to be, to me, to be the biggest value of it. That TDD is actually a really great way of avoiding the build-up of technical debt. I particularly like this quote from Bob Martin. You know what you believe by observing yourself in a crisis. If in a crisis you follow your disciplines, then you truly believe in those disciplines. On the other hand, if you change your behavior in a crisis, then you don't truly believe in your normal behavior. And I've seen that quite often where people tend to have this idea that we'll do this quickly and we'll drop the unit tests. And if that's the situation, then it's probably worth asking, what value are you getting from your unit tests anyway? Is it something that you're just doing as a kind of cargo cult thing, something that feels like you should be doing it? Or is it something that you gain value from? And if you are doing the trade-off of perhaps testing less to get into production, then when are you actually going to pay that back? So taking the situation where technical debt has built up, how do you get out of it? And obviously greenfields are quite rare situations. Very quickly, as you saw with my example of Gradle arguing with Jenkins, greenfields very quickly become brownfields, very quickly become kind of wastelands of unpleasant code. And the answer that most people seem to come up with initially is burn everything, start again from the beginning. And this is kind of a triumph, it's a real feeling of optimism, the idea that we've learned from these mistakes, if we start afresh, at year zero, everything will be fine. The big thing that usually goes against this is kind of history, that the only time you've built a system is ended up with technical debt, that all the trade-offs and the compromises you've made have led you to this point once before. And I quite like the description of kind of rebuilds as a cultural solution to a technical solution to a cultural problem. Unless you've made some really big difference to the way in which you work, you're going to run into the same issues right from the beginning. The last time you built a system, it was so horrible you want to start from scratch. In that case, you probably need to take what you've got and start improving your processes, and maybe later look at starting again. Obviously, the first thing you need to do is to be aware of hackers and try and deal with these existential threats. And whenever I've been putting stuff live, security is the one thing that terrifies me. The idea that somebody can get in and charge customers, the idea that they can steal the data, leak it, that's the thing that really, really makes me nervous. And obviously, that's the first thing you need to check. Is everything secure? And there's some great projects on the web like OWASP. Has anyone used this or sort of checked on this? So quite a few nodded heads. Fantastic database of what vulnerabilities are out there, and worth going through and just checking regularly that you're up to date with that. Another one of these big risks is user data. So Cory Doctorow, the writer, described personal data as being a little bit like nuclear waste, that if you have a lot of it around, it's dangerous. It needs to be stored very carefully. And the risks of data being exposed or tampered with, again, it's one of those things which, you're probably not going to have a problem with it. It'll probably be fine, but if you do have a problem, it's going to be incredibly costly and come around incredibly quickly. So I think security and user data are the two things you really need to watch out for early on. But with technical debt, I think it's a little bit like real debt, like financial debt. The first thing you need to do, and the first thing that people always get advised is, find out how much you owe. And technical debt is obviously a little bit hard to quantify. There's various tools out there that will kind of tell you that you have this amount of technical debt. And the number's kind of cobbled out of nowhere, just as a sort of rough idea based on standard metrics multiplied by a financial factor. And obviously, it's very hard. Unless you've tracked how much work was done to repay the debt, you'll never work out how much it cost. But one of the things I find quite fascinating is the idea of kind of Fitbit monitoring. So who here uses a Fitbit or a step counter? So yeah, a few people. So obviously a lot of people get really into this for the idea of improving their fitness or losing weight. But the thing is, the number of steps isn't a clear correlation to, for example, how fit you are. But it's a reasonable proxy for a lot of people. So I find that the number of steps I walk doesn't really affect my weight at all. It doesn't improve my fitness whatsoever. But for other people, they've found incredible results from this. So I think the idea is, if you can find a proxy for your technical debt, start tracking lots of different numbers and see if any of those start reflecting things getting more difficult or easier. Things like how difficult it is to make a release, what's the time between releases, how many bugs are getting added to Jira. Even something like lines of code. Obviously, lines of code are a terrible metric for most things. But if you look at how many lines of code are being added into your repository, for example, that's an idea of a very, very vulgar metric for how fast people are working. So start using that sort of thing to quantify changes in the technical debt. And this gives you a bit of an idea of how deep the problem is. The next thing you need to do is make a repayment scheme with your creditors. So you can't pay off technical debt just through promises and good intentions. You've got to basically put the work in. So it's going to mean slower forward movement or more resources being added to it. In the same way that you can't pay a credit card debt, bill off by taking loads of holidays to New York and buying huge rounds of drinks, you're not going to pay off technical debt by keeping adding features. You need to work out how you're actually going to pay this down. You've also got an ongoing issue of depreciation. The idea that even if you just leave your code out there, it's going to become less and less effective as time goes on. So things like the Heartbleed vulnerability. So loads of people had perfectly secure sites sat on the internet, and then vulnerability gets announced, they're all vulnerable, everyone has to patch. Apparently there are tens of thousands of sites that still haven't updated from that vulnerability. So over time, bugs are going to be exposed in your frameworks, in your platforms, and those are going to need to be kept an eye on as well. There's also the need to just keep an eye on learning about stuff. So having your own personal projects is a way of just keeping up to date with what's happening in technology. Now, I tend to be very suspicious of the idea that got very popular for a while ago, that GitHub should be your CV, that after a hard day's work, you should ignore all your other commitments and then write more code. But I think equally, trying to find time to either run a personal project in the latest frameworks or to learn a new technology is incredibly valuable and well worth spending the time on. So to summarize, if you're in this sort of mess, I think the answer is check for any bankruptcy threats, anything that's going to be incredibly dangerous if it does cause a problem. Start quantifying how much debt you have and whether it changes. Devise your repayment plan, how you're going to start paying this down. Then look at preventing further debt, how you prevent depreciation, how you prevent other problems. And how you're just going to keep things running smoothly. But I think the important thing is that the way you do anything is the way you do everything. Ultimately, if you're running a system and adding code and adding technical debt, then that's just going to accrete. Whereas if you're finding ways to pay it down, that's obviously going to be incredibly beneficial. And I should probably just make my usual recommendation for the Michael Feathers book, Working Effectively with Legacy Code, which is a superb book about just ways of dealing with this and getting control over difficult situations. Thank you very much.